let's talk about dependency injection and what that is, why do we use it, and where's the standard come from. So a lot of you have used dependency injection. We use it in the Facetto Word application we're making. But a lot of you don't really understand and have asked the question, why do we do it in the first place? Yeah, we can see how to do it. We can see that we add it, dependencies, then we pull those dependencies from a provider and then we make use of them. But that isn't the issue. The issue comes in, why we're doing this in the first place. So a lot of you that haven't built large applications or are, early in the career of development, simply follow along and accept and trust that this is a good thing. But a lot of you now want to know why. What's the purpose of it? Why are we doing it? What's the benefits? So that's what I'm going to kind of explain in this video, along with some diagrams and source code, and try to really nail down the purpose of why we use dependency injection. So to do that, though, we must step back and first talk about generally application development. So for dependency injection to work, you must first develop an application. And really, in your mindset, you must develop an application in a certain way that leads you to then be able to make use of dependency injection. So I'll talk about how I develop applications. And again, the guys that watch me, you'll know I don't read books. I don't follow guidelines. I don't even read up on terminology. So, I don't really follow anything online as such. So this is my interpretation of dependency injection, how I use it, what it means to me, as well as how I make applications. So this isn't how everybody should do it. It's how I do it. And I'm, giving you that knowledge. So on that basis, basically, when I make applications, and this is what I feel should be the way of making applications, what you want to do is to make each part of your application a separate single block, and more so a reusable block. And then you bring all these blocks together to form an application. So let me give you an example. If we have a file manager, a cache manager, a web API manager that talks to our web server to log into our server, a backend database on our client to store the login credentials. All things like this are bits of code that we could write, and we could make one big monolithic application and just write all this in one application, no problem. But then let's say we decide to use SQL Server and we bake all this into one application. And then we change our minds. We want to use MySQL or some other database provider. Now that's baked into our application. It means we've got to change our main application, our entire code. We've also got to change anywhere we've made reference to that database. And once you make a large application, you'll soon realize the impact that has. To a simple change of, let's just swap out a database, can turn into a month's worth of development. So at first, you want to make your code to make it better and more reusable and friendly, is you want to really make these small reusable blocks of code, I'd call them. So if you're going to make something that handles files, .NET Core typically handles, your files for you. You just do file.read, file.write, file.open, things like that. But you add your own wrapper around that. You want to have error handling, so you want to try catch and then report to an error system. So you typically make a file manager. You'd make a database provider that do things. And these really are generic. They don't have to be specific to your application. So the next 10 applications you make might want to use a database provider. So the key is, and the point of something we do in code called dry, which is don't repeat yourself, is to try and make code that you write once and you can make use of again in the future. So what you want to do is to make a database provider that can be given some parameters like a connection string, and then do a generic job. So it wants to be able to, connect to a specific server. Then it wants to be able to maybe create tables, read data, write data, maybe simply perform a query, just send an actual statement of query. And on top of that afterwards, you can now use that SQL code block, if you will, that project, and reference it in your application and then make use of that. And then where the specifics of that come in, so in our Facetto Word application, we want to log in to our very specific table and database. The application layer, rightly so, tells the database the specifics. It says, I want to do this, I want to create this table, I want to do this exact detail. So the blocks of code that you write, which are basically projects that you can compile into single libraries that you can reuse, should be generic. And then the application layer should be the thing that tells those generic blocks, right, you all come together to form this application, and I will give you direct instructions. So now what forms your application, your true unique application, how it looks, how it functions, what it does, is the application layer, the very top layer of your application, not the underlying blocks of code, these small chunks of code. So that's how I write code and how I feel it should be written. There's no real point in not doing that. And what you should end up with is a bunch of libraries or projects that have all these, small, or not necessarily small, but basically these chunks, these modules that you can pick and use. The issue comes, and this is starting to approach why we use dependency injection. The issue comes when you want to talk, modules want to cross-talk, if you will. So we have a web API project that wants to query a web server. That's fine. It goes and talks to the web server. It's logged in. And now the web API layer, or any layer of your application, any module, wants to now store those login credentials. So it wants to store them in a database, and it knows it wants to store them in a database. So now your web API project would typically then cross-reference to your database module. So now you have a web API and a database module, and they want to link to each other and cross-talk. Now, that's all okay, and that's what most people will do at the start. But what you've done there is now given these two projects a cross-dependency on each other. So that means now, if you want to change your SQL database for MySQL, now your web API layer needs to change as well. So you really want to avoid these cross-dependencies, because they soon grow from one reference going across to, oh, now I need a reference to that project, so now I'll reference over there, and then you end up with a big, long list of cross-dependencies, and basically your application's no better off than how it was written in the first place. So the issue and the reason kind of dependency injection comes across and is, has a purpose really, is due, I'd say, again, this is my personal experience, is due mainly to the cross-dependency issue. What you want is to have a module that only references kind of a core library, a core piece of function, and the same for every block of code in your application. And then it's at the application layer, the last top layer, which we'll look at in a minute on a diagram, that then brings all these modules together and forms what is your application. So the only place where code has to change when you change modules, you remove and swap out the function, is the application layer. And that's, to me, where it should happen, not in the blocks and the modules themselves. So we can use dependency injection to remove those dependencies. Let's talk about a few benefits first before we go into a diagram. So obviously, firstly, the benefit of doing modular blocks of code and structure is, one, is the reusability. As we've mentioned, we can take a block and reuse it in another application because it's generic. It's simply, say, a database provider. You can make use of that in another project. The second one is the fact that it is modular. So it's a benefit of being modular, which means you can remove one module and put in another one, which means, say you wanted to test your whole application, but disregarding the database, or you wanted to force the database to act in a certain way. By changing one module and one line of code in your application layer, you could remove the real database and inject a mock database module into your application. So now you can have a little block of code that responds in a consistent way, and that leads to unit testing and the ability to unit test. So you've got the unit testing, you've got modular benefits, you've got extensibility, and I guess the last major one is once you start working on a big project and this grows and you have 10, 15, 20 developers working on it, each of these modules can be worked on and compiled completely independently of the application without even being aware of the application or its needs. So that means you could put 2 developers working on an SQL module, 2 on a file module, 2 on an API module, and the rest of the team working on the overall application. So it allows growth as well. So this kind of structure of just making your code in these kind of modular blocks, which is nothing specific to dependency injection, this is mostly modular development, has all these benefits. And then to make it suitable for dependency injection, you simply have to make sure those blocks are, like I say, basically generic, that they can be used and reused, and they stay at a very generic level. And your application then adds the special sauce that makes your application. So they're the benefits, and really that's enough talk in terms of just explaining why we should use it and what's going to happen. And now we'll move on to a diagram. So if we just take a quick look at this diagram here, and we're going to talk through this, and then we've got another diagram. So we've got here a fairly standard looking application, at least the way I develop them. And this is just more of a blockish diagram. It's not specifically accurate or specific. I just wanted to give you some visual. So what I tend to have in most of my applications is a very low level universal core. And you might have multiple cores, but basically the point of the core is to add functionality, base functionality that all of your applications across all of your scope, so your desktop apps, your Android apps, your unit testing, the back-end web servers, the front-end web servers, everything in general in the scope of your entire project and typically your entire company at that point would have this universal core. And this just adds generic abilities like we've done with the DNA framework. So this adds abilities like file logging, exception handling, dependency injection, things like that. So this would live typically in universal core. And as the name suggests, it's universally usable. And then what we would do, and I've really only chucked this web server in here to show you the fact that Universal Core references other projects completely. This I just quickly chucked together a few bits to kind of show you, but ignore the web server for the most part. And I've put my attention into this diagram. So once you've gone above the Universal Core, you then have a very specific client core, and this would be used across multiple solutions. So these thick black borders are typically solutions in Visual Studio, and the greens are projects. So I've kind of tried to show it that way. So the client core, as the name suggests again, is for all your clients. Well, you have multiple applications that are clients. All of them are meant to be the same thing. So you have a Windows desktop application, you can have a Linux and Mac application, you can have an Android and iOS application. They're all meant to do the same thing. Like when you download say Twitter onto your phone or Twitter onto your computer. It's the same application, it's the same client. It's built for different devices, but in theory it's meant to be the same thing. So the client core is to bring together things that you want to use across your clients. And obviously this means that this has to be cross-platform capable, but luckily .NET Core allows that. So on top of the Universal Core, we then have this client core. And this is really then where everything to do with all of your clients that's shared can be and can live. So this should be able to contain most things. Your file manager, your cache, your relational data, your view models, things like that. And then say you now want to make a WPF solution, you would then implement specific versions of your dependency. So this is now these file manager, cache manager, relational manager. These are the modules we spoke about, and these are the actual implementations of the modules. So instead of directly having a file manager project, we have now an interface that simply says, I want a file manager, and I don't know what type it is, but what that will allow, as you'll see in a minute, is that the cross-dependency we're talking about. So say this cache manager wants to store its cache in the file system. It needs to talk to the file manager. So if we reference the Windows cache with the Windows file manager, we've got a hard dependency. Now, when we move it to another application, or the logic of the code is in a certain place, when we come across to another application, you've got to break a dependency, or you want to change the file manager, you've got to change this, as we mentioned. So instead, what happens is that all of these projects, and including the top levels, well, all of these projects here, rather, only really reference the core. So if the Windows Cache Manager or the Windows File Manager or Android File Manager, any of them, want to talk to any other block on this level, what they should do, and what they do through dependency injection, is instead of the Windows Cache talking straight to the File Manager, Windows File Manager, it instead talks to the client core and asks the dependency injection to get me the current file manager. So the Windows Cache comes down here, says get me the file manager, and it says, okay, now write me a file. The client core goes then, this is the current file manager in use, and it tells this to do a job. So the dependency path is kind of down, then back up, down, then back up. So this client core, or potentially universal core, depending on how low level you get, stores your dependency injection and your services, so it can provide the services back to each block. So what that means is this is kind of a central core, and all of your projects, all of your modular blocks, the database handling, the files, the cache, the API managers, all really just reference core for the most part. That's all they reference. They don't reference each other. They don't reference the application above. They just reference core. And they do all of their communication through the core, asking for these services that they need providing to do their job. And then finally, the top layer of the application is the physical application itself, the WPF application, the Xamarin application. And these now say, right, this Windows project decides that it wants to take this Windows file manager block, this Windows cache manager block, inject them into core as dependencies, and now they can work together. And the Android decides to pick these. Now, just as easily, the Windows WPF solution could say, I don't want to use the Windows file manager block. I want to make use of this mock file manager block over here. Or I want to make use of a new file manager block that some third parties made. And all it has to do is swap out the Windows file manager block with another block with one line of code. Now, the Windows cache manager isn't concerned because it talks to the provider down here and then talks back up. So we'll see that in code. So this is one diagram. I've prepared one other. So let's just take a look at, pop over to this one here. So this is more of a reference diagram. This is where projects, all these are projects. Every one of these blocks is a project, every single one in Visual Studio. And I've colored them just so you can see the dependencies. And don't let all the arrows scare you off. So that the main point and the purpose of this is basically to show the dependencies and where they lie. So as you can see, the client core and universal core, you can class as kind of the core layers. So all you focus on, if you look at the black and blue arrows, and you can see that this level, these are your modules, your generic modules that aren't really specific to your application as such, the fairly generic blocks. They only reference cores. They have no other references anyway, so they don't cross-reference each other. Even though they talk to each other, what they do is they go down and then back up, and down and back up, and that's how they communicate, to remove this cross-dependency. And that allows us, as we mentioned, to now remove this entire block here from the application. Say, inject the mock file manager, and now the whole application will still work. It's just instead of using the Windows file manager, it will make use of the mock file manager. And we'll see this in code. I'm going to do a quick code demonstration on this as well. But the point of this was to try and just visually show you that all of your modules, all of your projects only reference core. So in your code, you should only be referencing core. And then finally, the very top level application, so the final layer, the top layer of your application that forms the actual product that you can run and view and use, now it says, right, I'm going to take the client view models, I'm going to take the Windows file manager, I'm going to take the Windows cache manager. So that's what all these references are then for. So this layer is your application layer, and it makes the specific choices of what blocks to use. The same with Android, it picks the Android blocks. But it can just as easily now, if you want to swap out this entire block, you can see the only pink dependency on this block is the WPF app. So it's simply the WPF app that has to dereference this, add a reference to this one, say, and make use of that. So if you keep this image in mind, and I'll upload this so you can make use of it, hopefully that's of some use. And as we show you the code now, you have in mind what we are talking about. So let's just pull up the code. So here's a quick sample project I've made. And the point of it is to try and show you the dependencies and the diagram I've just shown in kind of a real world, really simple but real world project layout. So here's my solution, my overall, this is a console application, but let's pretend this is a WPF application. So this is my overall solution. Here's my WPF application, if you will. I know it's a console application, but this is the application layer. Here's the core, which could well be universal core plus client core. It doesn't matter for the purpose of this. The point is it's a core library. Then we've added a specific file manager, so let's call it Windows File Manager. Then we've added a logger, so that's just a general logger. And then we've also added the mock file manager to show that these two blocks can be swapped out. Now, the first example I want to show you is that core has no dependencies, or no dependencies upper layer. So this is the lowest layer, which also means that you could select everything except core, right-click and unload, and you can build your project. So you can see down here at the bottom left, it's built successfully. So this has no references and no relevance to any of these. It can build independently. And just the same, and very importantly, and this is one thing you want to keep an eye out for, if we now pick a file manager, even though it's going to be used in the application, and even though it's going to talk to the logger and talk to potentially many other services, it has no dependencies on anything except core. So if we were to build this now, just make a change so you can see that it's building successfully. But if we go in here, you'll see we have a dependency provider.logger.log message. So we're actually logging a message, and we're making use of a logger, potentially this logger, that isn't even loaded, available, or even been made in code yet. And yet our file manager can make use of this, and I'll show you how that is in a minute. But the point is this module only references core. So we can now develop, we could send these two projects off to a development team, and they could produce this entire module. Just the same, if we were to unload the file manager and load the logger, and again, think of these as the blocks, you can see that this only has a reference to core. So this also compiles, which is fine. And if we unload that block and reload the mock file manager block again, only references core. Even though, again, in here we make use of the logger. So all of these blocks, these modules, are only reliant on core, which means they can all be developed independently, as we mentioned, and produced independently. And the way they talk is through core. So all I've chucked in core, to keep it nice and simple, is a really basic dependency injection. And don't get me wrong, this is not dependency injection, and that's not the purpose of this video to show you how to use it. I can do that in a separate video. But what this is to show the point of dependency injection. So the point of dependency injection is firstly to have a provider, something you can add dependencies to, and then they can be provided back out. So to do that, the simplest thing I can do to show you the point is to simply make a static class that has a bunch of prefix dependencies. This is not what you typically do. Your provider would typically say service provider.add singleton. So you can add any kind, but for not to confuse the purpose of what we're trying to show here, I simply made two prefixed dependencies, if you will. Now they're not implemented, they're simply saying the dependency provider can provide me a file manager and a logger. And I've quickly just made some interfaces to show that as well. So we have something to go by. This now defines what the file manager should do without actually implementing it. So now we can implement the file manager, which we do here as a file manager, and the mock file manager can implement it. So now we can have either one of those stand into our application as the file manager. So if we go to the top level application and we take a look at the program, first thing we do is just say hello world. And then here is where you would typically inject your services. So you wouldn't typically do this. You'd typically have, say, some dependency injection, and you'd say add singleton. And you see this in Facetto Word when we use the dependency injection in DNA framework. And then you potentially say it's an file manager, and I want it to be a Windows file manager as the instance. And you kind of do this to add this specific dependency of a file manager is sorted and resolved using this specific implementation. So to show that in our really basic demo, we simply directly set the interface to the type we want to use. So this is simulating injecting services into the dependency injection. And then all we do here is now make use of it. So in our application, we want to log a message. We don't directly call the logger and log something. We now go through the dependency injection provider and we say, right, get me the current logger in the system and log me a message. And then we want to write to a file. So we do the same thing. We say dependency provider.filemanager.write some data. And then we read it back. And then finally we log it just to show the point. So how to run this application. And we'll just step through it line by line. I've got to right click and set this one as startup. So if I now run this and we see here, so dependency provider is now going to make a new instance. So right now it's null, doesn't exist. We're going to make a new instance of a Windows file manager. So now it's set, same for a logger. And then when we go now to the dependency provider.logger and .log message, if we F11 into this, you'll see it's going to do the get of the logger, which is going to return the logger instance. And then if we F11 in again, you'll see now we're in this specific instance of the logger that we created here. without referencing it as such. Now, we're obviously in the application layer, so it doesn't matter we have that reference, but you'll see in a minute that we make use of those references outside of the top layer. So this will log a message, which is here. So you can see now we've got hello world and we've logged some message. Now this gets to the fun part. So now the file manager wants to write some data. So we F11 in, it's going to go to the property, and it's now going to end up in the Windows File Manager. And I can see here the Windows File Manager has no reference to a logger, but it's now going to use the dependency provider to get the logger, which it knows nothing about, and tell it to log a message. And now that message that we've just written there, about to write, has now been logged. So now what's happened is this application, or rather this module, the Windows File Manager, is now making use of another dependency without having a cross-dependency reference on it. So it knows nothing about this. What this also means is we can now swap out the logger for something totally different, and this module and all other modules that use the logger have no concern. They can compile, they can run, there's no issue whatsoever. Same as we read some data back and we log some data, that's kind of just showing a bit of code. So let's show you now where the power of the dependency injection comes in. Let's say we've decided, as we mentioned in the example, we no longer want to use a Windows File Manager. So that would have actually written to my desktop as well. So if I go to C users Luke desktop, and you can see I've got test.txt, which has opened up in my other window down here. And you can see that's written, this is my test. And that's because the file write data from Windows File Manager actually does write the text. So that's worked. And that's where I put the example text file. But let's say now we don't want to do that. And also, if I just quickly re-show you something, the logger says I'm going to write this data to the path. It reads the data back, and then it echoes out what it read back. So it's going to say, I'm writing this is my test, and then the file manager logs the this is my test, and then it reads the file back, and it's the same. So what I've done, just as a quick demo, say we now want to swap this file manager for a whole new one. It's not typical to swap a file manager, but let's say this was a database provider. That's very common to do so. And you can imagine how much your database provider will be used throughout your application. But let's just do the file manager for the sake of simplicity. So now instead of using your Windows File Manager, the one line of code I was talking about that needs to change, the only line in your entire application that needs to change to swap out all of the file manager is to change this line, or even this one statement, to now make use of a mock file manager. And that's it. Your entire application now no longer uses the Windows file system. It's now going to pass to this mock file system, which, again, just to show you a purpose, this could be a unit testing structure that purposely fails. Like if we have fail on purpose, we could send the wrong thing. This has, on get file data, it ignores the path and simply returns a private string. And on writing, it ignores the path and simply sets the variable that gets returned to the data, and then it appends mock, so it's not the right data. Now, what we could do is make use of the if fail on purpose, then that equals that, else data equals data. So we could basically say, I know I haven't put comments in here, so don't do this. This is just for a really quick, clean example to show you what's happening. So now, if we were to set up this specific mock file manager to fail on purpose, it would return the wrong data. So by default, that's going to be false. So we should return the correct data. And more importantly, that it won't write a file now. It won't do anything with a file. So if we were to run this example, where's my breakpoint? There we go. You'll now see that we get the logger. It's logged that it's about to write stuff. And now if we F11 into this, you'll see we're now in the mock file manager. So now we're no longer in the Windows file manager. This is going to still talk to the logger, and this is going to tell it to mock this information out, appending mock to the end, which it won't do because it's not set to fail. So this will now return the correct data. And then our application will do the same thing. It'll actually ask the file manager, which is now the mock file manager, to return that data and display it to the screen. So now we have what looks exactly the same. It's wrote some data and then it's read it back. But this hasn't ever hit the file system. Its purpose has changed. but our application hasn't had to change anything. Our entire application still works with one line of change. So let's say then in here, we wanted to fail on purpose. And again, it's just one line of code, nice and simple. And now we run this, and this time, we don't need to really hit that breakpoint. If we run this, you should see that now we've read back, this is my test mock, so it's actually replaced the functionality. So that's really all there is to it. So that's the basics of dependency injection, and that's the simplest way I can explain it, and hopefully kind of show you, until you make a big application and you've had this requirement, if you will, you've had this, this need for swapping out blocks of code or reusing a massive block of code you've written, you kind of don't appreciate the huge benefit of doing it this way. But hopefully this, along with the diagram, the explanation, and a bit of sample source code that shows you actually swapping out a dependency. I know it's a really basic example, that's the purpose, to show you at its most basic form how by changing one line of code you can swap ultimately your entire application's use or dependency on something else without changing anything else but one line of code, and that's the real benefit. And you can see that now in our Facetto Word application. If you look at our Facetto Word where we say .use SQL server, I believe the statement is, or .use SQLite, we can easily, and we have done, simply swap between SQLite and SQL server with one line of code, which is to say .use SQL server instead of .use SQLite or SQLite. So that's really the point of dependency injection. And I kind of hope this video explains that and you understand, why that is and why we use it. And I've put a lot of time and effort into the diagrams and the explanation to keep it simple, but hopefully make you understand why we use dependency injection, and also kind of how it works, that it's simply a provider. You simply, at the application layer, you add your dependencies, and all that really does is goes down to a core that you're referencing that holds a reference to that, specific implementation. And then when something else in core or something else referencing core asks for that, it returns that. And there's a bit more to dependency injection. It's singletons, transient scopes, but you don't need to know that to understand the point of it. If you keep it simple and say, it's basically the top layer application says I want to use a Windows file manager, a logger, and this, that, the other. And now all of your specific modules can simply take the core and say, give me the implementation of this, regardless of what it is, and I'll make use of it. That power comes through the interfaces. So hopefully it was clear anyway. As always, just leave comments if you're unsure and I'll answer questions. I do answer as many, I pretty much answer every question I get asked, so long as I get notified of it. So any confusion or difficulties, just ask and I'll answer. But hopefully this has been useful and it's explained the topic well.